everything's upside down.
Right.
Power is overhead.
Right.
So you see the metal buzz bar that runs the length of the building. That's a 250 amp, 3-phase buzz bar. That has 32 amp breakers all the way across for each rack, and there's one on either side. A and B feeds. Each rack is fed with both. And we'll do a quick look at the back in a minute, and we'll get a look at the PDUs, how they're wired. Behind you, we have what we call a HMI. It's a human machine interface. So it is a piece of software and a piece of technology that allows a human, while in the data center, to see vital statistics: temperature, relative humidity, positive pressure, and whether or not a door is open. So as you see, someone just buzzed in there, the door opened and closed. You can see what frequency each fan is running at. Pick another one at random. 10.4 hertz, current is 0.7 of an amp, and it's detecting 22 degrees centigrade. You can go up top. This is all very similar to the BMS that I showed you a little bit earlier. So it's more or less the same thing. It's just that this is without windows and all the rest of it. This is the actual human interface to the data center. Let's put it back to normal there. In this cabinet here, I won't open any of the cabinets, but essentially we have a and B fed fan board which controls all the fans in the building. And if a side PDU goes down, the B side fans go into an automatic emergency mode, and they'll ramp up. But it's not A and B in terms of fans. Every other fan is an A and a B fan. So in each side you have redundancy from a failure point of view, from a power point of view, and we have fail safes built in throughout. These obviously are power meters. They can tell us the current draw on each phase. So there's very little power actually being consumed at the moment, because the data center is in the pre-ramp up stages of having live equipment in it. Now behind you we have the core network for this location. So we've taken 2 racks from phase 1 for the core network, and this will actually feed the entire building, and currently does actually. So we have fibre coming in from here and from here, from 2 separate physical locations. We had to put our own ducts in the ground, so all of this is completely resilient physically and logically. This is one of the fibre connections comes in. This is actually from BT, so that comes in there, and that's our connection, which comes back up into one of our core routers. And essentially what that does is that there's a similar box to that in Dublin, and we have a similar box to this in Dublin, and they're talking together, and they're building up a mesh. And then we have 10 gig fibre between here and the other side. So we have an internal ring and an external ring for maximum speed, maximum availability, and maximum flexibility. In years gone by, we had trouble with the flexibility of the network, the way it was designed. It was kind of designed for a kind of smaller hosting type organization, whereas now Blacknight are a hoster and we're a carrier. We actually we sell bandwidth onto customers. We have customers in Carlow, we have customers out of the 2 data centres in Dublin. We actually have one live customer hanging off this equipment already, the one of our neighbours here, but we were able to run fibre through the existing ducts that we put in into their premises. So they have a gigabit connection in their office supplied by Blacknight. Up here we have, this is our core access layer, which is every rack has a connection back to the core access layer. It's an aggregation point. And then there's similar switches to these in the back of the racks. I can show you those as well. And then we have up here, we have various management levels, which are basically the kind of control infrastructure behind the scenes of all this, if that makes sense. So there's layers of redundancy throughout. Even if the power went, lights would stay on, fans would stay running, etc. All that good stuff. Let me see what else is showing you. We have CCTV cameras at the appropriate locations. They're IP, they're streaming 24/7, 365, and recorded. We have emergency fire exits. We have differential pressure sensors at either end of the building. If you see the plastic pipes coming out of those H&C modules on the wall, they're detecting the pressure difference between upstairs and downstairs. Because obviously above us there is a giant AHU, which is an air handling unit as such. It's all talking back to the central brain of the data center as such. We'll have a quick look inside the one of the hot aisles. I'll just give you a quick look at the back of all the equipment. In the network racks, we decided to use orange power leads to indicate importance. So if you see an orange power lead, you never unplug it, you never touch it. Simple as that. You'll also notice the cable management is very, very neat and tidy. It's all Cat6, all tested end to end with the highest possible rating possible. We have multiple reams of fibre coming into this box. This is a special type of fibre that you can actually tie it in a knot and you won't break it. Fibre typically would be very brittle, but with this type of fibre that we've used here, we've alleviated that brittle nature. Now,
see the insulation in here then?
Yes, exactly. This is a hot aisle. This is not going to be a nice place for a human to be in.
Yeah.
Simple as that. Down here we have a typical network configuration in a shared hosting rack. We have two 48-port switches. Well, actually we have three 48-port switches. This is what we would call our public network. This is what we call a private network. And this is management and KVM. So every server we would put in here would have a minimum of 3 gigabit connections. We'd have front, we'd have public, private, and management. And you can also see we have Blacknight branded PDUs, and all of these are centrally wired back to a monitoring system. So we can see kilowatt hours used, the load on each PDU, and we can graph the load of the data center on a per rack and a per pod basis, if that makes sense. So when we install servers here, there'll be up to about 40 servers, and they'll all be wired back into these switches. And an interesting fact about these particular Juniper switches, typically a switch heats from front to back, and because of the nature of this data center, the hot aisles are going to be quite warm. When we ordered those from Juniper had them back to front, so the cooling comes in the back and the hot air comes out the front. So they're the opposite way around of a typical switch.
Because you want access to the switches in the hot aisle. You want the front of the switch to be in the hot aisle.
Exactly.
Yeah.
We call those TOR. They're top of rack switches.
Right. Yeah.
And because they're in the hot aisle, they need to take the cold air from somewhere to keep them optimum.
Yeah.
Now, to be fair, that equipment's probably rated up to 34 degrees centigrade operational temperature anyway. Yeah. But there's no point in
driving it the opposite way to the way it's supposed to be.
Exactly. Because what you end up with is you end up with loops of air within your your cabinets, which is inefficient. Point to note, in all the racks, we have sealed between them. During testing, we had blades of cold air coming through the racks, and they used to actually hit these temperature sensors.
Okay.
See them?
Yeah.
And what we found is the gap between each rack, those blades of cold air were shooting through and were telling the return air fans to ramp down. Even though the ambient air was 35 degrees, the air around them was only 24, 25 degrees because of the blades. So we've sealed in between all the racks on top and at the front, so no cold air can pass from the cold aisle except if it's going through a piece of equipment. And we've done that throughout the data center. And as you can see, we've insulation the whole way down, and that's a steel panel behind that, separating the cold aisle from the hot aisle. And again, that's been done to maximise heating and cooling efficiency. We never want hot and cold air mixing. They always have to be separate. So that's pretty much it. Again, just a few points to note. Each fan is isolated. So if I turn that off, that fan will switch off. The rest of them will go into a fail-safe mode in this aisle. Here's the noise. And two things are happening right now. The hot oil fans are ramping up, the pressure is going down, and the supply fans are going to ramp up to deal with the suction. Now you can hear it's really quite noisy right now, and it's almost, if you could see your hair moving in the wind, I can tell mine. If I turn that back on, almost immediately everything's back to normal. There's a much more gentle ramp up for a number of reasons. You never want to increase humidity by dropping the temperature too quick, and for that reason the fail-safe is a slow ramp up rather than a full steam ahead ramp up. But during our testing we put 100 kilowatt load with all the fans running, and we tested various failure modes, and again you can see there's temperature sensor controls and differential pressure sensors between each extraction fan and the fan chamber above. And the reason the differential pressure sensors are there is to determine whether the fan is supplying enough air. In an ideal scenario, all of the fans should be running around the same rate and the pressure should be the same throughout. So if the pressure drops above any one of them, a couple of things could have happened. The fan might be broken, the control loop could be malfunctioning, or there's baffles above the fan. One of them could get stuck because they flap when the air pressure increases and decreases. So if say some of the baffles stopped working, or they became lodged or dislodged or whatever, you could have a failure mode, and that's why those are there. So that's pretty much the hot oil. This was originally going to be just a fan chamber, but because we're humans, we kind of wanted it to be semi-usable by a normal person. Here we have, you see these big red pipes, that's our fire suppression system. It comes in a bunch of different zones. Zone 1 is a duct probe. So in the cold air supply from outside, we're sampling the air for contaminants. Be it, let's call them smoke particles for one, or other contaminants such as large volumes of sand, or let's say you're in the desert for example and you had a sandstorm coming your way. The zone probe, the duct probe would detect the increase in particles in the air and shut that, switch the chillers on and go full reset. So that's what the duct probe does. Then we have our standard fire suppression system, which is actually pulling air samples into the smoke heads, which are these white heads. There's 3 in each coal aisle, and there's a couple dotted around different locations. They're smoke detectors. So there's that's the second control loop, and the third control loop is the slightly smaller red pipe, the plastic one that runs back into the hot oil, and that's a VESDA. It's very early smoke detection system, but it samples so many particles per second, and if it detects any kind of particles in the air within the pod, it's able to tell us. And the system's in auto manual mode, which means that someone actually has to press a button to crank out the FM200 for safety, really. But typically, if we wanted to, say there was a fire, if we were away from the building, we could tell the BMS to dump the gas, and then the fire would be put out. It starves it of oxygen, fills the room with FM200, which is non-lethal to humans. There would be no oxygen in the room for up to 3 minutes. So that's why we have fire exit push bars on both entrance and exit doors. So if your hands are on fire, you can back into the door and get out safely, for example. Other interesting things of note: wireless phones, temperature sensor for the utility space, which is where we're standing. There's no moving air in this area, so if this gets really hot, we know something's wrong in the rest of the data center as well. We've Wi-Fi throughout the building using Ubiquiti Wi-Fi equipment. Another IP camera, and various parts of the fire suppression system behind you up on the wall. Excellent. That is the data center.